Hi there. I want to start out standard deviation in a different approach. I started out by explaining the formula and what it's used for, and I don't think it went that well. There's the honest truth. So I want to try it a different way. I want to start at the back end and work forward. Okay, so let's start with an example. Let's imagine I invented a handy dandy cell phone case, and it is solar powered. In other words, it's pretty cool because you no longer have to plug in your cell phone. All you got to do is leave the case out in the sun for, 15 minutes a day, and it completely charges your phone. It's going to be revolutionary. But it's still in the testing phase. Okay. And I tested 1,000 of these cases to see how long they would last, right? And the mu is 3 years, so that's the mean or the average. And you know from Friday's class, that means that about half of them are going to last less than 3 years, and about half of them are going to last more than 3 years. And our sigma, or standard deviation, is 0.5 years. And I did that because, you know what? Let's pretend I had a really cool calculator or some smart engineer on working for my company that calculated this stuff out for me. And right now what I want to do is I want to figure out what kind of warranty I want to put on it, right? Because you buy something, you want a warranty, right? These are going to be $49.95. I made that up just now. And you're going to have some kind of a warranty, but I don't want to replace all of them. I'm going to replace like a small amount, but I don't know how long I should make the warranty. Should it be for a year? Should it be 2 years? Should it be 5 years? And standard deviation is going to let me, and shortly you, figure that out. Truth is, the moment I see a mean and a standard deviation, right away I draw my graph or my chart. One that we drew, and it goes like that. You make your nice little curve. And like I said, I tend not to draw the fancy bell curve. I just draw a half circle is good enough. We divide it in half, and that's our mean. And I know that's going to be 3 years. And then I need to make this into quarters. So I take it and I divide it in half, and then I divide each of them in half. Doesn't have to be exact. It's pretty close. Okay. Next thing I do is I put my percents in. Now you will always have the formula sheet or a printout or something. I've just done enough of these to know what these numbers are. So that's saying in this area, that represents 0.15% of the population. And this box in here represents 2.35%. And on this side is frequency, because it always is frequency. In other words, how often does that happen? And if I put my hand over this, remember, this part of the graph is identical every single time you draw it. Now we're going to use our standard deviation. And each one of these boxes, or these distances, represents one standard deviation. So plus 0.5. Oh, I wrote too small, too big there. 2.5 years plus 0.5. 4 years plus 0.5. 4.5 years. And we don't worry about that back one because this technically keeps trailing off. You might have something that lasts a really long time, is way out there. And then we do exactly the same thing, going the other way, except you're going to subtract. I can't remember which student told me that they did that every time, and it just makes it easy. 2.5 years, 2 years, 1.5. Okay, so this is how long the cases last. So again, I tested 1,000 cases, and this was the data we got. So, how do we want to proceed? Well, let's do it easy. Let's say, as I said, we're looking at warranty. I hope I spelled that. I think that's it, warranty. Let's say, seems reasonable. What if I say anything? No, I'll replace. Geez. Anything that breaks in in 3 years. I guess I really could have just said, I'm going to give you a 3-year warranty. Well, let's see what that actually means on a graph. If I decide to do that, that means I'm going to replace everything in this area all the way up here until I get to 3 years. And if I do that, that means I'm going to replace all the ones that break down before 1.5 years, and the ones that break down before 2 years, and 2.5, all the way up to here. So I want to see what percent of my phone cases I have to replace. So I'm just going to add them up. 0.15 plus 2.35 plus 13.5 plus 34. And I know for a fact that's 50%. Now, I'm not really good in business, but I don't think I want to set out a warranty where I'm replacing 50% of my product. I'm going to lose an awful lot of money doing that. That seems way too high. Well, what if I change it? How about just 2 years? How about a 2-year warranty? All right, well, I like using my highlighters. That means I'm going to replace anything that's less than 2 years. So that's going to be 0.15 plus 2.35, and that gives me 2.5%. Well, that's not bad, right? 2.5% replacement. So let's just put this in perspective. Let's say I have an amazing first few months. Let's say we sell, what do you think? This is pretty impressive for $49.95. 10,000 cases. Okay. If I do a 2-year warranty, that means 2.5 divided by 100. Wait, I'm converting it. There's a lot of ways to convert with percents and decimals, but this is a quick, easy way. Times 10,000. $2.5. Yes, I can. Divide by 100 times 10,000. All right, that means I would have to replace 250 cases. And now I'm going to just really admit that I have no idea if that's a good deal or not. But I know if I use this warranty, I'd be replacing 5,000 cases. Now, you might decide that even that's too much. Well, what if we said a year and a half? So 1.5 years warranty. Well, if you look on the graph, then it would just be that bottom corner there. So it'd be 0.15%. And I'm going to do the same thing. So 0.15, oops, try again, 0.15 divided by 100 times 10,000, 15. Okay. So that's maybe how manufacturers figure out where their warranties are going to be. They'll make some decision on, you know, how many they're willing to replace. And then based on testing and standard deviations, they can decide where that's going to be. Now, for some of you who are thinking, that's kind of weird to have a 1.5 year warranty, like 18 months. Well, truth is you could actually figure it out for 1 year, but that involves some extra math that we're not quite ready for. And I'm hoping this makes more sense for you. Okay, that's what we do with this stuff, is we're able to make some decisions. Now, one thing I should clarify. So we said we had a shipment of 10,000. So we sell these 10,000. If I pick a phone case out of there, okay, so I randomly open a box, I pick one out, I don't know how long it's going to last. But I know in that case of 10,000, there'll be about 15 of them that are going to die before a year and a half. And there's going to be about 250 in total that'll die before 2 years. But it never allows you to look at a specific case and say, oh, well, this is the one. It's just as likely that if I pick one, maybe I'm going to be lucky and I'm going to get a case that lasts over 4.5 years. Okay, I hope that makes more sense. And remember, don't get worried about it. Just always start with a picture. I'm going to do one more. Okay, just for practice. And you don't even have to, now we're going to make something up on the fly. Okay, let's say the mass or weight, Labrador Terriers. Okay, that's my handy dandy jelly bean who seems to, oh. Where is she? There she is. She's sleeping on the floor behind me. Which is amazing because usually she gets all stupid when I decide to make a video. Okay, let's say the mean is 60 pounds and the standard deviation is equal to 5 pounds. Okay, so we're going to draw the graph. Okay, it's supposed to be symmetrical. That one looks a little off, but that's okay. There's your middle. Get used to using the mu. I notice here I just wrote mean because that's what my brain thinks. And then we're going to divide it in half. So this section, divide in half, and then divide each of those in half. Like I said, some of you are clever and you can just go and make it all even. I can't do that. All right, and before I do anything else, as I'm writing it, I'm thinking it's not terribly important that you put the percent signs in there, but it's a good idea. All right, and frequency. Same every single time. Now we're going to put our mean. So 60 goes here. And I'll put a little label, mass of doggo. And my standard deviation, this is my sigma. So, whoops, +5, +5, +5. So this is going to be 65 pounds. This is going to be 70 pounds, 75 pounds, and -5, -5, -5. So this is going to be 55 pounds. This is going to be 50 pounds. This is going to be 45 pounds. Okay. So there is our standard deviation on mass. So kind of what that means, let's say we had 100 dogs. You'll have to forgive me because the decimals are going to make a mess here, but let's say we had 100 dogs. That means in that 100 dogs, there would be 34 of them that have a mass between 55 pounds and 60 pounds. And there would be 34 of those dogs that are 5 pounds heavier, between 60 and 65. Then it gets weird because when I start doing that, there'll be 13 and a half dogs who are between 50 and 55. There's going to be about 2.35 dogs, so about 2 dogs that are going to be pretty small, between 45 and 50, and 0.15. Okay, so it's pretty unlikely in 100 dogs you're going to have somebody lower than 45 pounds. If we go this way, we're going to have 13.5 dogs there, 2.5. So lots of dogs in the middle, very few that are going to be in this area, under 45 or over 75 pounds. Now, Miss Jellybean, that I just did our little flash there, weighs 70 pounds. Let's figure out what percent of dogs of the labs are heavier than Bean. She was just at the vet a little while ago, so I know she actually weighs 70 pounds. Okay, so what percent of dogs are heavier? Oopsies. Okay, so I'm going to find my 70. And it says heavier, so we want higher. So it's going to be this area here. And then all we do, oops, sorry, is we add them up. So 2.35 plus 0.15 is equal to 2.5% of Labrador retrievers in general are going to be heavier than 70%. And that's all there is to standard deviation. Yeah. The warranty one made sense. This is just a random question of how many dogs are going to be bigger than that. Okay, what if we wanted to know how many dogs are going to be less? So what percent of dogs are less than 65 pounds? So first step, make sure 65 is one of my bottom numbers. I call them my magic numbers because it works so well. So there's 65. Now in this case, it says less than that, which means I want to take all the dogs that are represented in this area, in that blue area. These are highlighters so I know which is which. So here we go, just add it up. 0.15 plus 2.35 plus 13.5 plus 34 plus 34, and that's going to be should be 84%. Okay, and the reason I could do that easily is I actually kind of cheated. I know that half of my graph is 50%, so everything less than the mean is 50. So I knew this part here, when I added up, is 50, and then I just added the 34. It was 84%. All right, I'm going to stop the video, and I'm going to post this, and I'm hoping if you guys take a look at it, it's going to become a little less scary. Have a delightful day.